Hello everyone, welcome to the channel Statistical Hub. This is going to be the lecture number 2 in the course SH201A. Okay, in this chapter or in this particular lecture, we are going to cover something about probability definitions, like different type of probabilities that we define. So in the last lecture, we started with a very basic concept like probability of any event. Let's say probability of any event A that was coming out to be number of elements in A divided by number of elements in the sample space. Okay, so this is like one way of understanding what is the meaning of probability, the chance of happening of some particular event. Now, how this probability is coming up? So this kind of probability that we decided or that we defined and we considered like one concept, the events are considered to be like equally likely. Equally likely. So this concept is taken up in the course of classical probability. Classical probability. So what is the meaning of classical probability? So this is based on the assumption that all the possible outcomes that we are having, so it is based on the assumption, that all the possible outcomes, are equally likely. So taking into consideration this concept, we are getting the probability of any event A that can be considered to be number of elements in the event A over number of elements in the sample space. Very generic, very basic, easy to understand. Like for example, you can think about this case that you are having some dice. Okay, then the sample space that will be taking up 1, 2, 3, 4, 5, and 6. Then you define probability of any event A. If I consider event A to be, that is taking 2, 4, only 2 elements. So this will be coming out to be 2 over 6. We are considering that all the events, all the possible outcomes, they are equally likely, they are having equal chance to occur in this particular experiment as the final outcome. Okay, this is like one understanding. How do we understand the classical probability? Now the point is it fails whenever the assumption fails. Whenever the assumption fails. Like that makes sense. Like if you are going to appear for some exam, then there is not this kind of structure that you are going to pass the exam and fail the exam like with half of probability. That is not fair. Like if you have studied enough, then it's like high chance that you may be having the chance of maybe 99% to qualify that particular exam. On the other hand, if you didn't study well, then there is a possible chance that there is 99% chance that you will fail the exam. Correct? So in general setup, in the real world, there is very less chance that the probabilities or the events that we are encounter, they are not coming out to be like equally likely events. Okay, so in this case, the probability, the classical probability that fails to play the role of like probability to make it understand like how the probability is coming up. Okay, now moving to the next kind of probability, the second kind of probability that is known as your subjective probability. Subjective probability. Okay, so how to understand what is the meaning of subjective probability? Okay, as the name says, it is some sort of like subjective probability. So like in very general setup, I can just simply say this is some sort of like judgmental probability. Okay, that depends on like person to person. Like if you say that, okay, sir, what is the chance that if I study from your course, from this particular lecture slide, I will be able to understand the concept of subjective probability. Now, from my point of view, like I'm designing the course, I'm making up this particular video lecture. So I will assume that the way I'm teaching up, that is like good enough to make you understand what is the meaning of probability, subjective probability, and all these concepts. So in this particular point of view, I will say that there is like 100% chance that beta, you will be able to understand this concept. On the other hand, if there is some other person, maybe some other teacher, he may be watching this particular video and he may be having some different thought that, okay, he can do it much better way. So according to his subjective, according to his judgment, he may say that, okay, 50% is the chance that the students will be able to understand what is the meaning of probability as explained by Rahul. Correct? That is the meaning of like subjective probability. So you can simply say it is based on the personal choice. This choice can be some sort of like judgmental choice. In the other hand, you can say it can be some sort of like experience, the past experience that people may be saying. Maybe just assume that, okay, there is some particular, like in our course, like at Statistica Hub, when we get some other students, some new students. So there are many times that one student, he took some classes like maybe in January 2023. Okay, then he returned back in January 2024, like for different course. So according to his past experience, he is able to understand that, okay, last time I took some classes and I was able to pass this particular course. So as per the experience, he's coming back for the same course or maybe for some different course in statistical knowledge. So in that context, we can consider this is some sort of like subjective thing. Okay. So in this particular chapter or in this particular concept like subjective probability, there is no actual calculation. Like you don't have to go for like any sort of calculation. This is directly based on the personal experience, the personal choice. Okay, so the main thing about this subjective probability is on the same topic, on the same particular event, there can be different probabilities defined by different individuals. So it can be like maybe it can vary according to individuals, according to individuals. The second point you can see is like, so technically there is no empirical rule. There is no empirical rule to understand this type of probability. Like I can't just say something. Okay. The third point, it is highly biased. It is highly biased. Like if you ask like someone from my team that, okay, is Rahul sir a good teacher? So like for that particular chance, like if someone say that, okay, sir, if I take up some classes with Rahul sir, I will be able to understand this particular topic. So my team, they are like highly biased. There is subjective thing. They will eventually say that, okay, maybe the topic is like very vast. If you take up maybe some advanced course, maybe some PhD level course, then only like if you go to my team and if you say that, okay, sir, I'm willing to take classes with Rahul sir, I will be able to understand this concept. So according to them, they will say that, okay, there is 99% chance that you'll be able to understand. So that is like some sort of like subjective probability. There is like highly biasness in the subjective probability. That is their personal choice, their judgment that, okay, we are working with Rahul sir, so we have to be in favor of that particular person. Getting the idea? So in the course of like subjective probability, you can find a lot of biasness that can't be just decided or that can't be just removed. Okay, that will already or that will always exist in the setup or in this particular experiment. So that was something about subjective probability. Okay, so that's how like we just go for the subjective probability, and you can just say the example can be considered like if you have to estimate what is the chance of rain today. So on the same topic, like, okay, maybe some particular person number one, they can say like there is 50% chance. Person number two, that can say 70% chance, and so on. So you can say these are some sort of like subjective probabilities. And how they are deciding? They are deciding according to their past experience or whatever they have just experienced in their particular life, maybe seeing the climate, maybe seeing the position of the sun, the humidity, and all these things that can play part in the course of subjective probability. That's the idea of subjective probability. Okay. Now moving to the more advanced version where we go for the axiomatic probability. Now that is a very nice concept, and that is like how the actual probability that is going to be defined, maybe the advanced version of the probability that has been introduced in the context of probability theory. Okay, so let's come to the probability. Okay, so before moving to the context of like axiomatic probability, I will go for something that is known as probability space. So what is the meaning of probability space? So we generally define the probability space by this form S, B, P. Very simplest form. This is how we define the probability space. So technically in this one, this S, that is the sample space. S is the sample space. B is the sigma field. And the P, that is the probability function. So we can see probability, that is some sort of function in which we are going to input something and it will be giving some sort of like outcome, technically how the function works. So that's the meaning of probability. So we are having the probability space S, B, P. S the sample space, B the sigma field, P the probability function. Okay, moving ahead, we know what is the meaning of like sample space. If I go for the B, the sigma field, technically the sigma field is a subset of it is a subset of the power set of the sample space. Getting the point? So we are having the sub sample space. Okay, you can make different subsets. Okay, if you combine all the subsets and if you make one particular subset, so this is like power set. So if someone who is unable to understand what is the meaning of power set, so it is the set of all the subsets of S. So S can have like, if S is having maybe n number of elements, so there will be 2 raised to the power n number of subsets. So this power set, this will be containing all these subsets. That is the meaning of like power set. And this sigma field, that will be a subset of the power set. Now the point is, sir, we can have like a lot of subsets for the power set. Okay, again, you can make like different subsets. So this B, this must satisfy some sort of like things or some sort of like properties. So which particular subset can be considered to be the sigma field? So let's try to understand this point. This B is a sigma field if we have certain conditions. The first condition that we have is the phi and the S, they must belong to the B. That the null set and the complete sample space, that must be part of this subset that to be considered to be the sigma field. The second thing, if A belong to the B, this implies the A complement that must belong to the B. And I hope you remember what is the meaning of complementary events. So if A is like passing the exam, A complement meant to say failing the exam, just opposite to the note technically. Okay, the third property that must be justified is some event A1, A2, AN. If these belong to the B, this implies their union AI, I running from 1 to N, or maybe infinity, that must also belong to the B, the sigma field. So that's how we define the sigma field. Okay, so we are having the sample space S. You make different subsets of the sample space. If you combine them, that is coming out to be the power set. Then we define some B. So we define something B that is the sigma field. And once we define the B, then we move to the concept of P, the probability function. So if I say P is some sort of like probability function, so to define the function, you have to define what is the domain, what is the range, correct? So we are having the probability function, probability function. So if it is a function, there will be some domain and there will be some range. Okay, so the domain for the probability function, that will be this B. So the sigma field is the domain. Okay, and the range, that will be 0 to 1, and in some cases it can be gone to 0 to infinity. That is a different setup. We are not going to discuss this right now. We will only take the subpart 0 to 1. So that's how we define the probability function. And once we define the probability space, the sigma field, the probability function, then we can move to the concept of like axiomatic probability. Okay, let's move to the axiomatic probability. So we are having the concept of axiomatic probability. So in the previous slide, I just defined something that is the probability function. So this probability function is considered to be like the axiomatic probability if it satisfies certain conditions or some axioms that I'm going to define right now. So the axiomatic probability that was given by A. Kolmogorov. This was the scientist who gave the concept of like axiomatic probability, and he defined that, okay, the probability function, it must satisfy the following axioms. Okay, and what were the axioms that he gave? So the first axiom that I'm going to write, that will be the non-negativity. What does that mean? So for any event A, the probability of that event that can't be non-negative, that can't be negative. Okay, so that means to say it must be greater than equal to 0. The second property that he said, that is like the union, like, okay, before moving normalization, I think normalization. Okay, that means to say the probability of the sample space, the complete sample space, that must be 1. Okay, and there is third more property, or the third axiom, that is the additivity. And this says that if you are having some A and B, if these are some disjoint events, then probability of A union B, that will be coming out to be probability of A plus probability of B. This can be generalized also. Like for n events, for infinite events, it can be generalized. So that is the concept of like axiomatic probability that we deal with. So the probability function that was defined on the previous slide, that must satisfy these three conditions, then only we define that probability to be axiomatic probability. And in our course, we are going to discuss more about the axiomatic probability again and again. So that's how the probability concept, or the axiomatic probability, the classical probability, these concepts are discussed. I hope that makes sense. You are able to understand the concept of axiomatic probability, the probability space, subjective probability, and the classical probability. Okay, moving ahead, we are having some sort of like examples that you can consider, some problems. These are very basic problems. If I say like this is a problem that is based on the classical probability. So we are having a bag. In the bag, there are like 5 red balls. We are having 5 red balls, 3 blue balls, and 2 green balls. Now this is like, what is the probability that you're going to do a blue ball? So very easy, like you can simply see the total number of balls, that is coming out to be 5 plus 3 plus 2, that is 8, 9, 10. And if I say you have to get a blue ball, so number of elements in blue balls, that will be coming out to be 3, or technically favorable one. Okay, so that is coming out to be 3. So number of favorable outcomes over total number of outcomes, that will give the respective probability. So probability of getting a blue ball, that will be this thing, that will be 3 over 10. I will be getting 0.3. The very simple format, very standard and most easy concept in the probability, the classical probability. Moving ahead, we are having the second probability problem, that is like estimate the probability of your favorite sports team winning their next match. Okay, so in this particular concept, like the subjective probability. So what can be the answer for this one? So this is completely based on the individual choice. So I won't be able to answer it very strictly. So it is based on individual with their past experience and judgment. Okay, so this is like completely based on the individuals who are this going for this particular experiment. Okay, moving ahead, then we are having the concept of like axiomatic probability. So in a class of like 30 students, so we are having total number of students that is given, total number that is 30. We are having number of girls that is coming out to be 18, number of boys that is coming out to be 12. If one student is selected, what is the probability the student is a girl? Okay, so very simple, probability that the student will be a girl, that will be coming out to be like 80 over 30. Okay, so that can be cancelled out. I think 3 over 5, that will be coming. So that's how we can go for like probability, the axiomatic probability, and the very basic, like this was again a very basic introductory lecture in which we discussed some concept about the classical probability, the subjective probability, and the axiomatic probability. I hope you're able to understand the concepts. That was all in the lecture number 2. Let's understand more advanced topic in the lecture number 3. We'll going for the concept of like combination P and C, and then we'll move to more advanced concepts in the probability. Bye. Thank you.